sir. This is Ayushan from ECEC. My roll number 24BQ1804G5. I am from second year ECEC, sir. Today's my seminar topic is first order stationary process. First order stationary process is a random process where the first order probability density function of independent of time. This means the process is constant over time. It cannot change with respect to time. At the statistical properties at given time. The statistical properties means mean, variance, like that. These are the statistical properties. These are not changed with time. The process is called the stationary process. So next, what is a stationary process? A random process where all statistical properties, mean, variance, moments, remain constant over time. Okay, key insight: probabilistic behavior remains identical regardless of time axis shifts. The process looks like same at any point. Okay, let us see that the graph. These are the does not change with respect to time. Mean, average, mean, variance, moments. The process is called the stationary. Okay, stationary process can be classified into two different orders based on how the probability density functions behave with respect to time. We already discussed that the mean or average does not change with respect to time. It is the one of the statistical properties. Time density function. Mathematically, this is expressed as fx of x1 comma t equal to fx of x1 comma t plus tau. T plus tau. Tau is the probability density function at one time and another time. Here the probability density function of f of x with respect to time is with respect at any time is constant. So the process is called stationary process. Okay, we already seen the mathematical definition of the first order stationary process. Fx of x1 comma t equal to fx of x1 comma t plus delta t. We can shift the t, but the density function value is same. What this means? The meaning of this function is the probability distribution function of x of t depend on only the values, not on the specific time t. Therefore, expectation of x of t equal to mu, that is constant value. Practical impact in our life. Mean behavior is predictable and stable across all time intervals. Okay, mean behavior mean the mean only depend on the change in time, but not the time value. Mean behavior is predictable and it can predict and it can be predicted easily and stable across all intervals. But the meaning of the stable across means the mean value at any time instant is constant, nothing but constant, but it change with respect to it cannot change with respect to time, and it cannot be infinity at any time interval. A fundamental requirement for reliable stochastic modeling. It was the one of the practical means in our life. The stationary process used as a reliable stochastic modeling. Key property about the constant mean invariance. Expectation of x of t is the function of t equal to mu for all values of t. The average value never changes with respect to time. Defining feature. First order stationaries guarantees constant mean, the most critical indicator of temporal stability. Important caveat: variance and higher moments may still vary with time. This is weaker than full stationary. Okay, first order stationary versus second order stationary. First order stationary, constant mean. Second order stationary, mean plus variance plus autocovariance. Okay, second order stationary equal to mean plus variance plus autocovariance. Third, stationary, all statistical properties. A process with constant mean but time varying variance is the first order stationary. Why first order stationary matters? Number 1, simplifies analysis, ensures stable average behavior, reducing complexity in stochastic modeling and inference. Second, critical for time series. Mean stability is foundational for forecasting, prediction, and reliable and statistical interference. Number 3, gateway concept. a stepping stone towards testing stronger stationarity conditions. They are second order stationary and stationarity. Example: white noise process. It was one of the example for the process, stationary process. The ideal stationary process: expectation of x of t equal to 0, variation of x of t equal to sigma x square. Sigma is the denotation of the sigma is the standard deviation, sigma square is the variance of x of t for all values of t. White noise, the ideal stationary process. White noise with zero mean and constant variance is both first and second order stationary. Okay, let us understand. White noise with zero mean, x of t, expectation of x of t equal to 0, and constant variance sigma x square is constant for both first and second order stationary. Each sample x of t has identical distribution regarding less of time. There are no temporal pattern or trend, completely unpredictable, perfect stationary benchmark. Okay, example for the white noise is a simple example of first order is stationary process white noise, where each sample is drawn from a distribution with a constant mean and variance. For instance, a random binary wave output that outputs are 0 1 with equal probability is first order stationary because its mean is always 0.5. Another example is the process where x of t is a constant y that is chosen randomly. A process that randomly alternates between 0 and 1. The mean is always 0.5 and the variance is constant, so that the statistical properties does not change over time. A constant random variable. A process where x of t equal to y for all values of t, where y is a random variable. Each realization of the process is constant value, and the mean of the process is expected value of y, which is a constant. Okay, non-example for stationary process: time varying mean process. Time varying means the mean value is changing with respect to time. Non first order stationary, a process where mean changes over time, violates the fundamental assumption. It was the one of the main condition for stationary process. A process is stationary, the process is not change with respect to time, but is non first order. It change over the time. Common violations: trends or seasonal patterns cause first order distribution to shift. Real world example: in our practical life, stock prices, temperature data. Stock prices are changing with respect to time. They are not constant values with respect to time. Temperature data, the temperature also changes with respect to time. Are economic indicators with system growth, means inherently and non-stationary. Okay, key distinction means the key point about the non-example: e of x of t depends on time, that is first order stationary, false. The another example is time where the let us understand. Let us repeat once. First order stationary, a process where x of t mean is not constant, such x of t equal to let us say x of t equal to, okay, let us take an x of t equal to a sin omega t, where a and omega are constant values. The expected value e of x of t equal to e of a sin omega t equal to a sin omega t, which is not constant and changes with respect to time. Therefore, the process is not first order stationary. Testing for first order stationary. Number 1, empirical distribution check. Verify if x of t distribution remains stable across different time windows. Okay, split data and compare the different time windows of x of t distribution. Next, number 2, compare segment means. The test whether means from the consecutive time periods are statistically equivalent using hypothesis testing. Number 3, distributional test. Apply statistical test to verify distributional invariance across time. Precursors to advanced test. Foundation for more complex stationary tests like ADF. ADF means augmented Dickey-Fuller. For unit root detection. Okay, these are the tests for first order stationary processes. for the process which is stationary or not. Okay, summary and takeaway. Core concept. Okay, summary and takeaway. Core concept. First order stationary equal to constant mean and time invariant distribution. Why it matters. Foundation of statistic process theory, time series modeling and statistical interference. In our practical life, essential for realizable forecasting, prediction and meaningful analysis of temporal data. Okay, thank you.